Good morning. As I mentioned in our last session, we weren't quite done with solving equations. I hinted that there was more to do when it came to solving equations with variables on both sides. But since it's been a couple days since our last meeting, I'd like to go back and revisit solving equations of various types. Remember that when we're going to find a solution, we're going to isolate the variable, and we could do that by either performing inverse operations. Perhaps we have to combine like terms. We might even need to distribute first. And then the last thing that we encountered was the collect variables on one side. So have your notebook out, and let's try a few problems. I tried to give you a little bit of a mix of different types of problems in this first couple sets before we go on to the new part of the lesson. In the first one, once again, we think about how we're going to isolate a variable. We look at both sides to begin with, and we see if there's anything to simplify on the left or simplify on the right. We also look for whether there are variables on both sides of that equal to sign. Since I see something that needs to be simplified, I'm going to start by my distribution. I now have a two inverse operation process left to go. I'm down to 5x is equal to 55. And when I divide by 5, my solution is x is equal to 11. Now in these particular problems, I'm not taking time to do the check, but I will be doing some with the check so that you get comfortable with that, because that will be required for some of the problems. In this next problem, I need to simplify on the left. Now there's more than one variable, but they're on both on the same side, so we're just going to combine. That's 7x minus 3x will give me 4x. 4x minus 4, plus 4 will equal 20. I will now subtract 4 on both sides. After I simplify, I have 4x is equal to 16. And lastly, divide. Solution, x is equal to 4. If I were to take this 4 and replace it for the variable in both places and simplify, the two sides will balance. In my third problem, I still notice that there's something to simplify. This time it's on the right, and these variables are on the same side, so that means I'm just going to combine them. Two inverse operations. Let's add 7 to both sides. Let's divide by 6. And now I have myself an improper fraction, which I can simplify. Once in a while, they will not come out to whole numbers, and that's perfectly fine. We think about in the beginning, there's always a whole number. That doesn't have to be the case. When I'm looking at my next problem, I see that I have variables on both sides of the equal to sign, which means I have to collect them to one side. That's the first thing you do when there's variables on both sides. I now have 3x minus 5 is equal to 13. I'll add 5 to both sides. I'll get 3x is equal to 18, and I'll divide by 3. X is equal to 6. So far this has been a sampling of the types of problems that we've already looked at last week. On to 4 more. See how you do with these, and then check back with me. The first one in this upper left-hand corner is just two inverse operations. I've got a negative 7x is equal to 21. Divide by negative 7. And you see in this one we did have integers. Okay, so I threw in some negatives here, and my answer is a negative 3. Here's where, when you do the check, you have to be sure that you have the right sign, because otherwise it won't come out. I have -7 times a -3 minus 4. That gives me 21 minus 4, which will give me 17, and it checks. On to the next problem. Distribution. -22 is equal to 2x minus 2. Once again, my variable's on the right. All I do is still isolate that variable. Again, I had some signed numbers. When I'm adding and the signs are unlike, I subtract and keep the sign of the greater absolute value. We'll be going over those rules if we need to. And then I get x is equal to -10. When I write the solution, I generally put the variable first because that's what I was solving for. Third problem, variables on both sides. Step 1 says I've got to collect those variables to one side. I am going to add 3x. This now gives me 8x plus 2 is equal to 26. I'm going to subtract 2. I'm going to get 8x is equal to 24. I will divide by 8, and x is equal to 3 is my solution. Once again, if that x was replaced in both places and simplified the left and simplified the right, if this is the correct answer, which is a solution, then the two sides will balance. Fourth problem, variables on both sides of the equal to sign, which means I'm going to use an inverse operation to collect them on one side. 4x minus 3 is equal to 41. Let's now add 3 and divide by 4. Solution, x is equal to 11. So that's everything we've done so far with solving equations. And these two slides were a good sample of the different types that we've already illustrated. So on to the change that I talked about. When solving linear equations, you may have one solution, which is every problem that we have already solved. We will soon find out that you could have no solution or infinite solutions. Let's see how that works. I start off with 9x plus 4 equals 6x plus 3x minus 5. Step 1, and now I'm writing once again the transformations. I'm telling you how I get from one step to the other in words so that you can play this back if you're not sure what to do. Since there are variables on both sides, but I notice on this side I can combine some like terms, I do that first. My second step says since there are variables on both sides, I need to collect them on one side. When I do it this time, my variables cancel out. I'm now left with 4 on the left and -5 on the right. That is a false statement, so then there is no solution to this equation. There is no value for x to substitute in that will ever make this true. Okay? Again, simplify your left, simplify your right if need be. Because there's variables on both sides, collect them to one side by an inverse operation. If they cancel out and the two numbers are not equivalent, then you have no solution. One more problem, and I see that I have, let's see, this does not belong there. Okay, let's pretend that's not there. Okay, so let's go on and say 2 times 2x is 4x, and 2 times 3 is 6. Distribute on the left. On this side, I just bring down my 4x plus 6. Now you should notice right away that these two signs are equal, but if we follow along and collect our variables on both sides, the variables cancel out and I am left with 6 is equal to 6, which is a true statement. That means that x is equal to all real numbers, which means that there are infinite solutions. Any number I put in here will make this equation true. So play this back if you need to. We'll review it in class today, and we'll do more examples. And until then, have a nice day.